Alright guys, so today we are going to be talking about friction and inclined plane. So a lot of you used to have issues with inclined plane. So my DM is so full to the point that please, when are you going to teach us this? We need knowledge on this. Anyway, now here we have a question. So one thing particularly about friction is, friction is the force that opposes the motion, you understand? And there are various places whereby frictions occur, whether when you're walking on a roadway, the automobile fire making a fence group with the roadway, advantages and disadvantages, you can compare them, source out how friction affect and daily normal life activities. Anyway, that's it. So we have a question here. An object of mass 15 kg at point of sliding down a plane inclined at 36 degrees to the horizontal. Find the least force parallel to the plane required to make the object to begin to move up the plane. It's not hard. The first thing to come to your mind is, if you have this question in your theory, what comes to your mind is drawing the diagram. But most likely you'll be seeing it in your JAMB questions. So no stress. So we have this like this. An object is moved up the plane. This is it. So don't forget, they said that what? They said we should find something. Find the least force parallel to the plane required to make the object to begin to move up. Alright, so this is our inclined plane. Then we have our inclined plane like this. This is our inclined plane, and this is the object. Alright, this is the object. This is the pulling force. Alright, then we represent this one as P. Alright, so we have your center of gravity. We have this place here. This is the frictional force. Okay, limited frictional force. I hope you are getting me, guys. So this one happens to be our W sine what? Sine theta. You can make this place our W sine theta. Then this one being our what? Our theta. So you can leave it as you are giving as what? As 36 degrees. Alright. So the angle it makes with an inclined plane. This is the object moving up the inclined plane. So we can now have you have this. So mind you, you must have been taught your reacting force and your what? And your work force. Okay? We have the frictional force and the reacting force. Alright? Alright, let's run this properly. So this is our vertical component, and this one is our horizontal component. Alright, so these are our reacting force. Alright, so it is balanced that way. So master this diagram, master it, so it will always be useful for you. Alright, so no stress. So this is the diagram suitable for this what? For this question. So shall we begin? Now, from the what? From the equation, what can you notice there? We will notice that our theta is what? 36 degrees, and our mass is what? According to the question, our mass is 15 kilogram. Okay, then what else can you notice from the question? Because you have to list out your parameters. Then our g is what? 10 meter per second square. Because in physics you have to list out your what? Your parameters. It is very essential you list them out. Alright, what else can you notice? You notice that your weight force, sorry. So what's our weight force? We need to calculate our weight force and our reacting force. So our weight force is what? Mass times gravity. Alright? So which implies that M times what? G, which is equals to, what's our weight? Our weight is 15 multiplied by 10. So we are having our weight force to be what? 150 Newton. So I hope you all understood. Good. Now, one thing is, so when we get to this junction, before we proceed further, I'd like to elaborate some things to you. So you have to know that for the object to move up the plane, like for this object to move up the plane, what happens? It must overcome the opposing limiting frictional force, F. Take note, I said for this object that we have here, for the object to move up this plane, it must overcome the opposing limiting frictional force, F, and what? And the parallel component of the weight force. and the parallel what? Component of the weight. What's the parallel component of the weight? The parallel component of the weight is W sine theta. Are you with me? The parallel component of the weight is W sine theta. No stress. Alright. Why the vertical component of it is W cos theta? That is the upward pulling force P. Now, what I'm trying to say is that is the force equals to the parallel component of the weight. That is, the pulling force is equal to the sum of the parallel component of the weight plus what? Plus the frictional force. Plus the frictional force. That is, the pulling force is equal to what? The parallel component of the weight plus frictional force. Because it is very clear that in this question, we have to calculate what? The pulling force. So, what is the formula? What is the equation for the parallel component of the weight? So, we have to break it down. That is P equals to W sine theta plus what? Plus F. No stress. Still, we have to break it down because we are not giving directly the frictional force. So, but what? But frictional force is equal to what? Do you remember that coefficient of frictional force is equal to limiting frictional force over R? When you cross multiply, you have F equals to mu what? Mu R. So you now have mu what? Mu R. So we can make this one an equation what? Equation star. So you substitute for F. You substitute for F in what? Equation star. So from here, anywhere you see F here, you put in this one. Then you have W sine theta plus what? Mu R. Is that clear? So this one be our what? Equation star what? Star 1. Recall again that R, because they didn't give us this one, this question of static friction, limited friction. They didn't give us the question of friction. So you also recall that our R from this diagram, what's our R? It is facing this, it is opposite. So it means that whatever you have for R here is going to be this one. Whatever you have for this one is going to be this one. So we are having our R to be equals to what? To be equals to the vertical component. The vertical component of the weight. That's W cos what? Cos theta. So you what? You substitute for what? For R in what? Equation star 1. So what do we have? We have what? This equation becomes P is equals to W sine theta plus what? Plus mu W cos what? Cos theta. Is that clear? So we can now make this one equation what? 1. Now recall that our question of friction is what? F over R. Okay? And obviously we don't have, they didn't directly give us F, they didn't directly give us R. So these two formula we have for this. We have, is either we have this equals to F over R, or we have question of friction equals to tan theta. So which means that if this one isn't working out, this one is going to work out. So that means we are using the other formula for this one to find this tan what? Tan theta. So that's tan what? Tan, what's our theta? Theta is 36. Tan 36, which is equals to, then this one in turn gives 0.7 what? 3. So that's at the end of the day, that's 0. Let's see. Tan what? 36, that is 0.73. So now we now have, then from here, then P equals to W sine theta plus 0.73 W cos theta. Okay, are we together? So our weight force is 150. Don't forget. So 150 sine 36 degree plus 0.73 into 150 cos 36 degree. Okay, so we are already plugging in those values we have. So sine 36 is 0. What? We have 150 into 0.58778 plus 0.73 into 150 into what's cos 36. Cos 36 is is 0.8090. Alright, so we now have 150 times 0.5878. So we have it's 8. The calculator does spoil. We have 88.17 plus 0.73 times 150 times 0.8090. So we have 88.5855. So adding it up with this 88.17, so we have 176.7555. So approximately 176.76 Newton. So that is our final answer. So that is our final answer for this question. Hence we say that the least force parallel to the plane required to make the object to begin to move up the plane is what? 176.76 Newton. So the force that is required to pull it up. You understand? So in cases whereby they ask you to calculate something like the force required to make it come to rest. So instead of having addition here, what you do, this one becomes subtraction. That is, the P is going to be equal to F sine theta minus what? F. So when it is the force required to pull it up, it's going to be plus. When the force required to move it down, that will make it come stationary, is going to be minus. I'm just giving you a logic. So there will not be point bothering yourself. Just write out this, then either plus or minus, you should know where they belong to. So I believe I've been able to convince you guys. So thank you for watching. Bye.